Welcome to Fast Math Solutions on Maths with EJD. In this video, we'll be looking at this question where we get to derive probability generating function from probability distribution function. And the question reads, a discrete probability distribution is defined by a random variable x, having a PDF probability x equals x is equal to b into 1 minus b raised to power x. Of course, since it's discrete, right, we have x equals 0, 1, 2, and so on. And b is constant, where b is constant. So find the PGF. PGF is probability generating function. So find the PGF for this distribution. Then use the PGF that you get in the first case to obtain the expectation of x. So that's what we are going to deal with. So let's go. So first of all, before you do probability generating function, you need to know what that is about, the definition, right? So we want to find the probability generating function for the distribution, whose PDF. So we have PDF, we need to find PGF, whose PDF is defined as what you have there, P of x equals x is equal to b into 1 minus b raised to power x for x equals 0, 1, 2, and so on and so forth. Okay, that's all we need to find. So I go marker hunting and I go for blue. Okay, so now let's do this. Okay. So first of all, you need to understand the definition of probability generating function, which is actually generally given as G of Z, which is equal to expectation of Z raised to power X. And that is actually the same thing as the summation of X, summation from X equals 0 to infinity of that Z now of small x, now that it's inside here, into, that multiplied by probability that big X is equal to small x, or the PDF in short. So this is the definition of probability generating function. Okay. So with this settled, now, let's move on and talk about how to deal with this. So since we know G of Z to be that, so it means we can say G of Z now is equal to summation from x equals 0 to infinity of Z of x, P of x equals x. And P of x equals x is this defined here. So we can just use this. So we have summation from x equals 0 to infinity of Z raised to power x into this P of x equals x is what you have there. So this now multiplied by b into 1 minus b raised to power x, like that. So we have it set up. So we need to just tidy things up. So you can see anything that has x can remain under the summation. Anything without x, like b is without x, it can go out. So we can have b out here. Summation from x equals 0 to infinity. Now you see z raised to power x and 1 minus b raised to power x. So they can be together. So we can have z into 1 minus b raised to power x. All right. So we can have that. Well, if you want to do some kind of, if you want to, to, we can already see that this is a summation, right? This is like a geometric sequence, or a geometric series rather. So it's more like you have b times, if you put this in bracket now, you have, okay, when x is 0, right? It means anything raised by 0 is 1. So you have 1 plus, when x is 1, you have z into 1 minus b, all raised to power 2. Okay, let me do it this way, some perfectionistic stuff there. So you have that brace. So when x is 0, you have 1. Anything raised by 0 is 1, as you know already. Then when x is 1, you have z into 1 minus b raised to power 1, or I mean, the bracket may not even be necessary because we just have z into 1 minus b straight. So when x is 2, right, we have z into 1 minus b, all of that raised to power 2. When z is 3, you have all that's z into 1 minus b, all raised to power 3, and so on and so forth. So now you see that this is a geometric sequence now, if you as you can see. And okay, I guess I want to change markers here. So this is a geometric sequence right there in the bracket, and it's like you're summing all of that from 0 to infinity, and that reminds me of okay, let's quickly take a break. If you remember the idea of sum to infinity in arithmetic sequence, sum to infinity sum to infinity for arithmetic sequence is defined as s infinity equals first term over 1 minus the common ratio. So that is what sum to infinity is like. That's what it is like. And you can see that this expression is basically sum to infinity in a way. Okay, let me just leave that. Okay, yeah. So you can see that this now infinity. So it means we are going to sum this whole expression down to infinity, as you can see, from x equals 0 to infinity. So that's basically sum to infinity. So you can jump over that, and then you go to talk about the generating function. So you can say g of z now is equal to b times, so for the sum to infinity thing, you can already see here that a is the first term, which is 1, and the common ratio is r. Common ratio, so you see that 1 times z into 1 minus b gives you this. So z times 1 minus b gives you the next one. So you can see the common ratio is z into 1 minus b. So with that now, we can have a, which is 1, all over 1 minus the common ratio, which is z into 1 minus b. So that g of z is actually b. Let me give some space to make things neater. So you see g of z now is actually the same thing as b over 1 minus b z, So that's what your g of z is going to be. So basically, this is the probability generating function for that PDF. Basically, this is it. So that means we have taken care of the first part of the question. The next thing is we want to use that PGF in A to obtain expectation of X. Okay. So okay, let me go marker hunt, once again and go for this. So to find the expectation of X given the g of z we just obtained, given g of z equals b over 1 minus b z. That's what we have. So we want to find expectation of X given that. So what does that simply mean? So the way to do this is actually that the expectation of X, we need to know that the expectation of X in this case is actually the first derivative of the generating function evaluated at 1. Now, what that means is that we need to find, so we need to find g prime z. That means you differentiate that with respect to z. That's more like the z of g of z. Basically, that means you are differentiating this expression with respect to z, basically. So once you do that, so that's the first thing. We need to find 1 g prime of z, and then the next thing is you now find g prime of 1. That means whatever any z you have, so you put 1 there, and that way you can get expectation of X as defined up there. Okay, so let's go for the final showdown, like I like to say. Okay, so we need to differentiate, right? So we have g of z. I think it's some small z, right? G of z equals b all over 1 minus b z, right? And we need to find g prime of z, right? So g prime of z is d dz of b over 1 1 minus b z, like that, and that is equal to, well, to make things easier, I like to do this. Let's say, you have the b there, so this one down here, it can go up. So, or better still, let me try to follow it gradually. So you have b over all this now, 1 minus 1 minus b z raised to power 1, right? We have that. So you can take it up. So we can do, we can do function of a function. So you have d dz of b out here multiplied by 1 minus 1 minus b z, all raised by minus 1. So I can even do braces here. So just like we do braces right here. Okay. So with this now, you can see that this b is constant. So if you do ddz of that, you can, of course, b is constant. You can leave that out here. So to do this one fast, if you follow my series on basic calculus, like, right, I talked about function of a function. And the way to do that is to 3 steps, just do 3 steps. This is what you are differentiating, right? So this power minus 1 up here, bring it down. So you have minus 1. That's the first step. And once you bring that down, once you bring that 1 down, okay, let me allow that the way it is. So bring down the minus 1, then multiplied by, differentiate inside the bracket with respect to z. So you can see this is 1 on its own. So differentiate this with respect to z, that's 0. But then you have this one with respect to z. If you differentiate this with respect to z, it only just remains minus 1 minus b. It just remains whatever is with z, because the z just drops off because it's z power 1. Then what's the last thing you do? The original expression, right? 1 minus 1 minus b z. It was raised to power 1. Reduce the power further by 1. That's minus 2 now. You see that? So with this now, of course, this b means b times, okay? So it means b times minus 1. That's minus b times minus 1 minus b. So that will be b into 1 minus b. And since this is raised to power 2, you can have all that all over 1 minus 1 minus 1 minus b z raised to power 2. Okay? So that is g prime of z. So we have done this first part. So the second part now, I want to evaluate g prime of 1. So because the expectation of x is the derivative of g of the probability generating function evaluated at 1. So this is basically g prime of z now. So you can say, therefore, expectation of x now is equal to g prime of 1. And that means that anywhere you see z, you put 1. So that means you have b into 1 minus b all over 1 minus 1 minus b into 1, all raised to power 2. So that you have b. So this is equal to b into 1 minus b all over, expand all this. Now you have 1 minus, minus 1 times 1, that's minus 1. Minus times minus, that's plus b times 1, that's plus b, all raised to power 2. And then this is equal to b into 1 minus b. 1 cancels 1, so you have b squared down here. And then b cancels b, so you have 1 minus b over b, all right? So you can say, therefore, the expectation of x for that particular PDF is 1 minus b all over b. So that means we have come to the end of that particular question. It's so interesting. So if you have not subscribed, be sure to do that and then hit the notification bell. So anytime I release a new video, you can get notified. Then share, like, and comment. For instance, this question I'm solving is actually from one of the people that follow this channel. So the person requested that I solve this, and that's why I'm doing this. So you can have such things, and we can take time to look at it for you. All right, so thanks for always coming here. See you in the next video.